is test about a population proportion. So we have P as the population of interested population, N is sample size, and X is the interested number of interested sample from N samples. Okay, and our hypothesis is P equal to P0 or not. So P0 is our hypothesized proportion. Okay. So if n is large enough, or n times p0 greater than or equal to 10, or n times 1 minus p0 greater than or equal to 10, we can just use that as the test statistics. So the distribution of this will transform from binomial distribution into normal distribution. Okay. This might not be very important for this course, but just for reference. Okay, let's see the example. So we have the mooncake product, and we know that the defective bags is about 10%. So the production manager changed the packing method, and he wants to check whether this new method is better than the old one or not. So he randomly select 200 bags and found that 11 bags is defective. So is this enough to conclude that the new method is significantly better than the old one? Okay, with alpha equal to 0.05. So let's go to the example, the hypothesis example 3 in this Excel. And we have P equal to 0.01, right? So this is actually P0, and then N is 200. P hat is the new P, okay, from the sample. So it's gonna be 11 divided by 200. Okay, so what else? We can do the calculation by using this formula, and we put P hat here minus P0 here divided by square root of P0 times 1 minus P0 divided by N. And with that, we have Z equal to minus 2.12, and the p-value is 0.017, and because it is less than the significant level, so we reject the new hypothesis, right? So for the calculation in this formula, we can calculate test statistics by just plug in the number and square root of P0 times 1 minus P0, and then divided by N, or close parentheses, and we got test statistics equal to minus 2.12. Okay, and you can see that this is a very small number. If we draw the graph of normal distribution, standard normal distribution, it's going to be around here, right? Minus 1.12. So the critical value, it is what? Here, minus 1.645. So because of this, we reject the null hypothesis. Minus 1.645 is come from what? Norm dot inverse dot s dot inverse, and then we put the probability of 0.1 here. Oops. What is our significant value is 0.05. So this is where we get minus 1.045. Okay, and the p-value, is what? Is norm dot s dot dist, and then the z is minus 2.12 cumulative. Yes. Okay, so it's about 0.17 here. You can use data analysis in Excel for this problem too, with a trick like this. So we have to create the result. Okay, for sample size of 200, we have attributes like this. The first column is going to be the ID, and number of sample is 200, so we have 200 ID. Okay. The next one is gonna be X. X is actually number of defective bags, and from our data collection we have 11 of them. Okay, and the rest will be 0. Okay, dummy is 0 and 0, just like the previous example. Now we can use data analysis t-test for 2 samples assuming unequal variance, and then we select the first variable range, which is this one. The second one is to trick that this is 2 samples, not one this is 2 samples, not 1 sample. Then, and the hypothesized mean difference is going to be 0.1, right? Because we think that's about 10%. And we check on labels, because we also select this label here on the top. And alpha is 0.05. We want the output to be around here, so G16 is about right, so we click OK. And we got this result. The test statistic is minus 2.78, which is more than the test statistic from manual calculation, because the assumption of the distribution here is t, not z, and the p-value is 0.0029, which is a lot less than the p-value here, 0.01. The t-critical value is 1.65 for one-tail test. It's a little bit different from the SAT distribution. So if we draw the distribution t here, okay, the mean is 0 and the critical value is minus 1.65. Okay, and our test statistic is minus 2.7, which is move further to the left here. So obviously we're gonna reject H0. So let's do the calculation for this test statistics. So it's gonna be x minus 0, the hypothesized mean, okay, divided by square root of variance divided by number of observation or number of samples. So we got this, and the p-value for this is t dot dist, and x is the t statistics, and degree of freedom is 1.99 cumulative, yes, okay, and t critical is t dot inverse. Probability is, in this one, for some reason they use right side, so we have to use 1 minus probability, which is 0.05. Degree of freedom, again 200 minus 1, so we got this number. If in case of two-tailed test, we just need to use t dot and dist, and then x is gonna be the test statistics. Oh, the p-value in this case is gonna be 1 minus 2 times absolute. The p-value for two-tailed test, again, so will be from the formula on the right, times 1 minus t dot dist absolute of t, here, close. Ooh, I forgot to put the what else do I need to put? This absolute, and then what else? Degree of freedom is 1.99 and true. Okay, and the critical for two-tailed test is t dot inverse. Probability is this one. Degree of freedom is this one. Oops. Oh, probability is gonna be this one divided by 2. T critical is t dot inv open parenthesis 1 minus 0.05 divided by 2, and degree of freedom is 199.